Okay, so welcome to Math2526. So we just have discussed the hypothesis testing problem. So for hypothesis testing, we just wanted to test the HA, just like we wanted to check two arguments or two hypotheses, right? So to make our decision, to make our conclusion, we say in statistics, nothing is 100% true or false. So for our conclusion cannot be 100% correct, right? So we wanted to know what is the chance that our conclusion is wrong. Okay, so at the first, so let's check what kinds of mistake we may commit in making our decision. So here we just focus on, we say HO is other people's claim, right? So we just focus on for other people's claim, we will accept or we will reject. So we say for their for this HO over reaction, we have two kinds of reaction. We reject HO or we accept HO, right? So we have those two kinds of mistakes. We reject HO when we should not reject or when we should accept. So this is the one of the mistake. And also we can make those mistakes. We accept HO when we should reject it, right? So we have those two kinds of mistakes. So we refer those two kinds of mistake as type 1 error, type 2 error. So today's topic is type 1, type 2 errors. Okay. So what is type 1? Or which one is type 1? Which one is type 2? So we just remember the type 2 error is more serious. So how can we judge, like if there's two mistakes, how can we judge which one is more serious? So let's go back to the original question for those hypothesis testing. So we just at the original, we wanted to test the people's claims. Usually they have those claims just come from pharmaceutical company, or their claim our new medicine is good. Okay. So then we want to test this, right? So just like FDA, they wanted to test their claim before their medicine can put it to in the market. So their medicine is good. So we say this is the claim HO. So our reaction is we believe them, we just take their medicine, or we do not believe them, we just refuse their medicine. Okay. So the mistake we may make is like they say medicine good, but we refuse, or we believe. Okay. Let's say, so for a mistake is we refuse good medicine or we take bad medicine, right? So they say medicine is good, but we refuse. Okay, and they say medicine is good, but their claim is not true. Medicine is not good. It's bad medicine, but we believe them, right? We believe them. We believe they are long claim, false claim. So which one is more serious? So usually this is serious. We believe them when their claim is wrong. Like when the medicine actually is not good, but we trust them, or we believe them. We just take a bad medicine. Okay, so this is type 2 error. So type 1 is refuse good medicine, or we refuse their claim when their claim is correct. So here we just refuse HO when HO is true, or we so type 2 error is we accept HO when HO is not true. Okay, so those are two kinds of mistake, type 1, type 2. Okay, so actually, that in our daily life, we for other people's suggestion, other people's advice, we also will make this. Maybe we'll make this kind of mistake. Their suggestion is good, but we don't believe, we don't listen to them, right? So the other thing is their suggestion is bad, but we just listen to them. We should reject, but we accept. So such a mistake is more serious, right? Some people give us bad advice, so we just take it. So this is a big mistake, the type 2 error. So some people give us good suggestion, but we refuse. So this is type 1 error. Okay, so type 2, we say type 2 error is more serious. So for other people's suggestion or other people's claim, our first reaction should reject, refuse, not believe, right? Not accept. Only we have some evidence, or only we have some enough information to make sure that their suggestion or their claim is true, we can accept, right? Okay. So before, when we make a decision, we use p-value to make a decision. But use p-value to make a decision is so quite complicated. So here we're talking about if we set a decision making rule. So we want to check whether decision making rule is good or not good, or can we use this decision making rule to make our decision? Okay. So for any making decision to judge a decision making rule, we need to check what chance we will make those mistake by applying your decision making rule. So we denote the alpha as a probability for committed type 1 error, and beta is probability we may make those type 2 error. So that's alpha and beta. So before we say we make our decision based on p-value, and the decision making rule is like that. The p-value less than alpha, p-value is small, we will refuse HO. P-value is larger than alpha, we will accept HO. So what is alpha? So before we say this alpha is a significance level. Okay, but more precisely, this alpha is the probability we will make type 1 error. So this alpha and this alpha is the same. Okay, so alpha is a significance level, and more precisely, alpha is the probability for making type 1 error. Okay, so once we have a decision-making rule, we need to find alpha and beta to determine whether this decision-making rule is good or not so good. Right? The decision-making rule is good or not good, we just check alpha or beta. So if alpha or beta are quite large, then this means we have a large chance to make a mistake if we apply this decision-making rule. Okay. Okay, so now let's consider some examples. Let's check the first example. So here, some people claim the average GPA for all students is at least 3.0 with standard deviation 0.3. So for this claim, now we want to test we check 25 students. So suppose we want to test their claim, so we will do a survey. We will check 25 students. So we set this very simple decision-making rule. So if class average is samples average less than 2.85, we will reject. So otherwise, we will accept. So claim says 3.00, like the average GPA at least. Claim this at least 3.00. So if we take a sample, if our sample means here more than 3, we will accept. If sample means here quite less, we will reject, right? So the cutoff point, we set the cutoff point is 2.85. So in this part, we will reject. And so larger than 2.8, we will accept. So we can say this is accept region, and this part reject region. Okay. So for such a problem, for this decision-making rule, we want to find alpha. We just check this decision-making rule is good or not so good. Or the probability to commit such a mistake. Okay, so at first we just this problem as hypothesis testing problem, HOHA. So HO, we put this as equal. So HO says 3, at least 3, we just put 3, so just check this point 3. So HA is not so good, so less than. So here we're talking about a GPA. So we say the high GPA means good. So low GPA means bad, right? So we say the HA is less than. Okay? Okay. So alpha, the top one arrow, is thus probability. We will refuse HO when HO is true. So refuse HO is when X bar is less than 2.85, right? When X bar less than 2.5. So when HO is true, means this is true. So mu equals us. So when mu equals 3.00, when HO is true, or when mu equals 3.00, we know this X bar will follow this normal. So X bar, we just apply the form, will follow this normal, right? Mu sigma, or radical N. So we just plug in here, let's say mu, so they say mu equals 3.00, and sigma 0.3, and N 25. Okay, so we know, so we find this is this normal is mean 3.00, standard deviation is 0.006, right? 0.3 divided by 5, right? Okay, so now find the alpha. It becomes easy. The alpha is this probability x bar less than 2.85. So when x bar follows this normal, okay. So such a problem just find a probability for a normal distribution. So we first step is changing this to standard normal, changing this to z. So x bar this minus mu divided by sigma. So we find this equal to 0.50. Okay, so then we so this probability, so it's just okay here negative 2.50. So we can check z table, find this probability. Okay, so let's check z table. Okay, so here I think we have z table here. So let's check 2.50. Positive 2.50 is 993A. Okay, so here we use 1 minus, right? Because this is positive 2. So less than 2.50. Like this actually is 2.50. So this part. But we want to find this part or this part. So, but anyway, this equals 0. Here's 2, 2, 0, 0. Okay. Okay. So this is our alpha. Let's see. So we can say this alpha is quite small. Also, we can say like apply this decision making rule like okay, cutoff point put to here 2.85 to make a decision. So such a decision making rule, we will not make a mistake, and the chance for us to make a mistake is really small. Make a type 1 mistake is really small. Okay. Okay. So let's consider this. So here, let's consider this problem. Okay. So this is 10 years ago. We found a mean and standard deviation results. So this mean and standard deviation is for 10 years ago. So this is for population information. 10 years ago, we have this information. So we wanted to check whether people's weight has changed over the 10 years. So to this purpose, so we intended to check 100 people. We will pick 100 people randomly. So decision making rule is thus. Okay, let's say that 10 years ago average is 163. So we just check whether they have some change, right? So we don't say the weight is increase or decrease. So change means both sides. So what decision making rule is if x bar is more than 65, we will believe the weight changed. Or if x bar is less than 162, we will believe the weight changed. So between this part, we will say the decision, the weight has not changed, quite the same. Okay, so for such a decision-making rule, we want to find alpha. Okay, so find alpha is we just check whether this decision-making rule is okay or not okay. Not okay means that the probability for mistake is high, then this means not so good, right? So let's say find alpha. Okay. So here, if we convert this as hypothesis testing, so this means that good is no difference, thus, and have difference. So both sides have difference, right? Okay. So alpha, let's check alpha. Alpha is top one arrow is just refuse HO when HO is true. So refuse HO, this case, we will refuse HO. We will believe have some difference, right? Or thus. So when HO is true, so when mu equal 163. Okay. So for such a problem, we use quite the same process. Like when HO is true, then we can find the distribution for X bar. X bar follows this normal distribution. Right? So mean, we just use the formula again. X bar follow this normal. Mu and sigma of radical n, right? Yeah. So here sigma is 7.2 in 100. So we know X bar follows this normal. Okay, X bar follows this normal. Then the X bar follows this normal, so we need to find this probability. X bar larger than 165 plus X bar less than 162. Right? Okay. So then for this probability, so we just use, changing this to standard normal. So minus mu divided by sigma minus mu divided by sigma. So here, maybe we need a little bit of calculation. So let's see, here z larger than. So let's see, what is this number? So a little bit of calculation. So this is 2 divided. Okay, so this is a 2.78. So plus, see, less than, so this is negative 1.39, negative 1.39. Okay, so now we can just check the Z table. Find this, check the Z table, we can find this probability. So let's say, so let me, so this is 2.78 and negative 1.39. So we just check 2.78, and but this is we need to use 1 minus here. So 2.78, 2.7 here, 8, thus, right? So this is the 9973. So we say this is, so we have 1 minus 9973. Okay, so this equals 0.027. Okay, So the other one is 1.39, 1.39 thus. Okay, 1.39. So 1 minus 9177. So equal, here is 3, 2, 2, 8, 0, right? Okay, so this alpha, we need to put them together, add them together. So 0, 0, 8, 2, 3. Okay, so this is like 5, 8, 0. So 0, 0, 8, 5. Okay, so we can put this. So finally, we say this equals 0, 0, 8, 5. Okay, so this is alpha. So like we have, if we apply this decision making rule, we have about 8%, 8% and 9% chance to make mistake. So this 8% is big mistake, big probability or small probability. So this is up to us, right? We can there's the chance of a mistake we can accept, or we should not accept. So this is up to us. But anyway, for this problem, find alpha, we are done, right? So we say alpha equals 0, 0, 8, 5. Okay. Now let's check this example. Like for the presidential election, some people always say, I will win the election. So we wanted to test their claim. We want to determine, will we believe him, or we will accept this claim, his claim, or reject his claim. So we will take do a survey, ask so many people. So if more than 5, 10 will vote for him, we will believe, we will accept his claim, or we will predict he will win. Okay, so let's say if 5, 10 thing, if like p hat, if 51%. So here we will accept. We will predict he will win. So here maybe we less than 51%. We will reject. We will not believe, right? We will not believe his claim. So this is the cut point. So this is what decision making rule. Okay. So we have this decision making rule, right? So we just do a survey. If the sample percentage, sample proportion is larger than 51%, we will predict he will win. Otherwise, we will not believe him. We will say he may lose the election, right? Okay. So let's say we want to find alpha. So what is alpha? Alpha is top 1 arrow. So what is top 1 arrow? Is we refuse HO when HO is true. So what is HO? Oh, when we will refuse HO, so here, yeah. So here actually this is his claim. He claim he will win. But we for HO we just put equal. HO is half chance to win the election, half. Okay. So here HO, so far HO is always equal. So sometimes we say HO is other people's claim, HO is our claim, but this is not always true. This depends. In here, HO is HA is their claim. Their claim he will win, right? And HO is our claim. Maybe still half. But anyway, let's go here. HO always equal. This is more important. HO is equal. Okay, non-hypothesis means no difference, means equal. Okay. So we will. So here, when we will reject HO, so in this case, we will reject. We will believe he will win. So here, let's see. So here we will reject. We focus on HO. So here we will reject HO is half. We will say not half. He will win, right? So here's a half. Okay. So refuse HO when HO true. So refuse HO, which part refuse? So this part. So when HO is true, is P equal thus. So when P equals this, so what is distribution for those things? P hat. So we know P hat follows this normal. P. So then sigma become PQ. Right? Sigma over radical A. So P hat will follow this normal. So we just plug it in here. So P, let's say P equal 0.5. And so this is P 0.5. Q is also 0.5. Okay. And N is how many people we will check. Sample size 1,000. So N is 1,000. Okay. So P follow this normal. Okay. So we find the P hat follow this normal. So after a little bit of calculation, find this P value follow this normal means 0.5. Standard deviation thus. Okay. So then for this alpha is P hat larger than 0.51. So then we just changing this to standard normal, like minus mu divided 6 sigma. So we have this. Okay. So say okay. So find this cut point is here. 0.625. So this is alpha. So to check the Z table, we only need 2 decimal digits. So we change this to 0.63. So now we just check the Z table. Okay, 0.63, 0.63. 3 here. 7357. But here we need to use 1 minus because this is less than the alpha is larger than right side. So this equal, let's say that here 3, 4, 6, 2. So this is our alpha. Okay. 2643. So we say this equal 2643. So just about 26%. So this means apply this decision-making rule. The chance to make type 1 mistake, or the chance to make a mistake is 26%. So this alpha is 26%. So usually we believe such a percentage is too high. Okay? Or you apply our decision-making rule, you may have the 26% chance to make a mistake. So this means this decision-making rule is not so good, right? So we need to change. Okay. But anyway, like here, to find alpha, so we just finished. We just this alpha is type 1 error. Just so type 1 error the refuse HO when HO is true. We need to find this probability. Okay. Okay. So this is today's topic. So we say type 1 error or type 2 error. So at the first we say type 1, type 2 error is type 1 is we refuse the people's claim when their claim is true. And the type 2 error is we accept their claim when their claim is wrong. So this is two mistakes. So we say type 2 error is more serious than the type 1. So for a decision making law, we need to check what the chance we will make. So the type 1 error, or type 2 error, right? Or find alpha and beta. So by now alpha is significance level, and also more precisely is the probability for making type 1 error. Okay, so there's today's topic. So we can stop here and we will. Okay, and thank you for watching.